Hello everybody, it's Wednesday the 10th of February and this is your maths lesson for today. We're going to carry on comparing and ordering fractions greater than 1. So for this you'll just need paper and pencil. Now for those of you who were really sad yesterday that I forgot to put the 4 a day on, I'm really sorry, but don't worry, alright? Your 4 a day is here, you've got yesterday's to do and you've got today's to do. So pause the video, have a go at Tuesdays, and then your answers will follow, and then you lucky kids have got Wednesdays to do as well. I know, you're welcome. I know I'm amazing. Here they are. Pause the video, have a go. Here are your answers for Tuesdays. Have a look and see how you did. And then Wednesdays will be coming. Here are today's for a day. Again, have a look, see how you get on. And here are your answers for today's. Have a look if you made any mistakes. Can you work out where that mistake was? And when you're ready, carry on and we're going to get started. We'll start with our get ready questions. Some questions to get our brains going, getting us thinking about the skills we're going to need for today's lessons. Pause the video. You've got 4 questions to have a go at, and then press play when you're ready to see the answers. Let's have a look and see. Question number 1, it says 11/6, which is an improper fraction because the numerator is larger than the denominator, is the same as something 36. So we know our denominator has changed from 6 to 36. Now in our 6 times tables, what would we need to do to change 6 to 36? Well, we would have to multiply by 6. So whatever we do to the bottom, we need to do to the top. So what would 11/6 is equivalent to 66/36. And we've got the next one here. Question 2, it says 29/20. And we've got to work out what symbol would go here for 25th tenths. Now again, the numerators aren't the same, the denominators aren't the same, so what fraction could we change to make it easier? And we could multiply 25th tenths by 2, change it to 50 tenths, and now we can see that we've got 29/20 and 50/20, and we should have said that 29/20 is smaller than 50/20. Then question 3, we've got our numerator missing, our denominator is 11ths. We've got the symbol greater than, and then we've got the number 2, and that 2 means to whole. So if we've got a denominator 11, what we should have thought about is what would it be if it was larger? Well, first of all, I know 1 whole would be 11 elevenths. So 2 wholes would have to be 22 elevenths. And I could have put then any number larger than greater than 22 would have been my answer. And question number 4, 16/14 and 8/6, what symbol would we put here? Is there any times table where 6 and 14 are? Is there any times table when 16 and 8 are in? And hopefully seeing 8 and 16 are both in the 8 times tables, we could have changed 8/6 to 16/12, and our numerators are the same, so we would have put our less than symbol. 16/14 is less than 16/12. Well done if you managed those. Now we're going to get going with our main session, and again equipment isn't really going to help us. It's going to be knowing our times tables to help us really answer these questions. So we're going to begin with having a go at ordering these fractions in ascending order. So again, that means going from the smallest fraction to the largest fraction. So what's the first thing we need to do? We've got our denominators and we've got our numerators are not the same. So we've got to think, what ones could we change? Are there any times tables, any numbers that we can see in our numerators that we could change into one of them? Or is it better to change the denominators into the same denominator? Have a think. I'll give you 5 seconds to think. Would we change the numerators or the denominators? So let's see. What we should have done was changed our numerators into 20ths. And remembered the rule, when the numerators are the same, the greater the denominator, the smaller the fraction. So to begin with, we could have changed our 2/3 times by 10. 2 times 10 is 20. So 2/3 is equivalent to 20/30ths. What would we have multiplied 4 by to change the numerator to 20? We should have multiplied by 5, and that would have become 20/45ths. And then with our 5/2, we would have multiplied by 4 and changed that to 28ths. 20/17ths we know we already have. So let's have a look and see. The smallest would be 4/9, then it would be 2/3, then it would be 20/17ths, and leaving it 5/2 as the greatest. This time it's your turn. Pause the video and have a go. Can you order these fractions in descending order? So if ascending means going from smallest to largest, descending means going from largest to smallest. And you remember that rule, when the numerators are the same, the greater the denominator, the smaller the fraction. So have a think, would you change your numerators or your denominators to the same? And what's a little bit of a trick that's happened with this one, is there any that you actually need to raise by multiplying, or might you do the inverse to change one of them? Have a think. Pause the video and have a go. Let's have a look and see. Well, what we could have done to make it a little bit easier is looked at that 60/32s and actually divided it by 2 to change it to 30/16ths. So some of you may have changed 30/19ths to the numerator 60, and the same with these, which is perfectly okay. But we're going to look at trying to change 60/32s into 30/16ths. So we're going to change all of our numerators to 30. So 1/2 times 30 is 30/60ths. 5/4 we would have to multiply by 6 because 5 times 6 is 30. And that would have changed to 30/24ths. And 30/19ths would have stayed as it is. And coming back to our rule at the bottom, when the numerators are the same, the greater the denominator, the smaller the fraction. So what would that order be if it was descending, largest to smallest? Well, the largest fraction then would be 60/32s. Then it would have been 30/19ths, then 5/4, and then 1/2. Well done if you managed to do those ones. Again, it's all about using your times tables and seeing what you can change your numerators and denominators to. Let's have a look at this problem together. This time we've got to order these fractions in ascending order. So we've got 4/3, 19/12, 11/5, and 10/6. And using this rule, when the denominators are the same, the greater the numerator, the greater the fraction. When we look at these fractions, can we change the numerators to one of these? Or can we change the denominators to one of these? Now if we looked, yes, we can change 3 to 12. We could change our 6 to 12ths, but we'd find it quite tricky to do with our fifths. Now we could change them all to 60ths. Another way we could do it, we could concentrate on those three. 4/3 we could change to 12ths to 16/12ths by multiplying by 4. 10/6 we could change to 12ths by multiplying by 2 to 20/12ths. 19/12ths would have stayed the same, but what's tricky is looking at our 11/5ths. And we looked at this rule before. We know that 10 is double 5, so we know 10/5ths is the same as 2 wholes, so 11/5ths is greater than 2 wholes. So that might help us to work it out. Now let's see and put them in order. The largest was 11/5ths, so we can cross that one out. 4/3 was the smallest, 19/12ths, and then 10/6. Very well done if you remembered that. It was a difficult one, but very, very well done if you managed it. Same again this time. Order these fractions in ascending order. And remember the rule, when the denominators are the same, the greater the numerator, the greater the fraction. And have a think, will it be the numerators or the denominators we're going to change? Which of those can we change and what can we change them to? And if we're finding it a little bit tricky, have a really big clue is have a really look at this one. 10/11ths. What do you notice about this one compared to the other fractions? Pause the video and have a go. Let's have a look and see. Well, we would have changed our 7/5ths, 44/40ths and 25/20ths into 40ths. We could have changed our denominators there. So 7/5ths we would have multiplied by 8, because 5 times 8 is 40, to 56/40ths. 25/20ths we could have multiplied by 2 to change to 50/40ths. And now we've got our 3 fractions where the denominator is the same. But we said at the start, what do you notice about this one compared to the other fractions? And hopefully what we may have spotted is this is a proper fraction. The numerator is smaller than the denominator, whereas these are improper fractions, meaning they're greater than 1 whole. So if this is a proper fraction, this means it is our smallest fraction. So 10/11ths is our smallest in our ascending order. And here would be our order for all of them. Have a look and see if you managed to do that. Well done if you did. Now we're going to look at a different kind of problem. We've got 5/7, and we know that 5/7 is less than 15 something. And we don't know what the denominator would be here, but we know that that is smaller than 15/9. So we've got to think now, what are we going to do to solve this? Well, first thing that we can do is we notice our numerators are 5, 15 and 15. So we could change 5/7 by multiplying by 3 to 15/21. Now we know that our numerators are the same. So we've got to think now, what could be a missing denominator? It must be larger than 15/9, but it also must be in between 15/21s and 15/9. So what could it be here? When the numerators are the same, the greater the denominator, the smaller the fraction. So it could be 11. It could be any integer between 10 and 20. So we're changing our numerator to the same as the other fractions and then looking and thinking what would go in between. So there might be a question like that coming next. And here it is. Using that same rule, what could you change? What could be the missing numerator for here? In the first one, we looked at changing the numerator, but this time, have a look at the denominators. What could you do to change these? And what would be a missing numerator? Pause the video and have a go. Think about your times tables carefully. Let's have a look and see. Well, we could have changed our 3/7 and our 14ths to 28 because we know that those numbers are in the 7 times table. So 3/7 we would have multiplied by 4 to 12/28. We would then multiply a number by 2 to get 28 for our middle fraction. So now we've got 2 28ths, 12 28ths. So what numbers could go here to represent our numerator? It must have been in between 2 and 12. Any integer between 3 and 11 would have worked, such as 7. Well done if you managed to do that one. It could have been 6. Oh, it could have been 3, which is its equivalent fraction. Let's have a look at this one now. We've got a half is less than a missing numerator and 21s, but that fraction is less than 18 21s. So this is our largest fraction. This is our smallest fraction. We must think of a fraction that goes in between. Now we know that half of 21 is 10.5, and any integer between 11 and 17 could be a way that we could work it out, because it would have been very tricky to try and convert. So 12 could have been one that went there. Now let's have a look at this word problem. Rosie and Jack each have 3 identical chew bars. Jack divides each of his bars into 4 equal pieces and eats 5 pieces. Rosie divides each of her bars into 2 equal pieces and eats 5 pieces. Jack says, "We've both eaten the same amount because we've both eaten 5 pieces." Now, have a think. Is Jack right? Could you draw some fraction bars maybe to help you, or think another way that you feel happy using? How could you find out? Is Jack right or not? Let's have a look and see. So, Jack split his into quarters. So here we can see his 2 bars in quarters. There's 4 quarters, 4 quarters, and 4 quarters. And he says he ate 5 of them. So he's got 12 quarters. And Rosie split hers into halves. And she has got 1, 2, 3, 4, 5, 6 halves. Now they both ate 5 of them. So Jack will have 7 quarters remaining, and Rosie ate 5, and she will have half remaining. So we've got 7 quarters and a half. Which is the larger fraction? Well, we could have changed our half into quarters by multiplying by 2. And we know that half is the same as 2 quarters. And now we know that 7/4 is larger than 2/4. If the denominators are the same, the larger the numerator, the larger the fraction. Now we've got some questions for you to try. Again, need you to try these by yourself. Pause the video and then your answers will come afterwards. For these ones, it says write the fractions in descending order. Remember, descending means largest to smallest. So again, having a look at your numbers and knowing your times tables, how could you change your denominator or numerators so they are all the same? And then that will help you remember. Try and remember the rules if the numerators or denominators are the same. Pause the video and have a go. Here are your answers. Now for question A, you have changed them all to 16ths, which is absolutely fine. Or you may have halved your 16/8 so that the denominators are 8s all the way through and changed your 4/5 to 8/10. With your part B, you might have changed your denominators to possibly a different number, maybe 18 could have worked. There's another way we might have done it, and the same with your C. But have a look and see how you did, and we've got another question coming. For this one, it says find 3 possible ways to complete each statement. So like we did before, when we had to work out larger, there are 3 possible ways that we could have answered these. So pause the video and have a go. Let's have a look and see. Here are your answers. Have a look and see how you did, and when you're ready, we'll move on to the next question. Here is this problem now. Have a read of it. Have a think what you might need to do. And the question is, who has more cake left? Can you work that out? Here is your answer. Hopefully you worked out. You may have drawn your fraction bars to help you. You may have converted your fractions to the same numerator or denominator. Either way, we should have hopefully worked out that Dora has more cake left. Well done if you managed to do that one. Now we've got an extra challenge for those who want to try it. This is something slightly different, and this is just recapping on your equivalent fractions. So you have a fraction picture to begin with. You need to look at the fraction picture carefully. You then have a statement. So for example, the first one says the shaded part is 1/4. So that means that all of these squares put together is 1/4 shaded. You need to decide whether that is correct or not correct. If you think it's correct, can you explain how you know? What do you know about what you can see here and how you know it's a quarter? If it's not correct, how do you know? Can you explain how you know a quarter isn't shaded? What do you know about your equivalent fractions that might help you? So pause the video and have a go at these two. And then after, the answers will come for these, and then there will be 2 more to try. Pause the video and have a go. Good luck. Here are our answers for the first 2. The first one was not correct. It was in fact 8/16 is shaded. So if we saw our lines, we had 4, 8, 12, 16 squares, and 8 of those were shaded, and 8/16 is not the same as a quarter. 8/16 is shaded, and this is equivalent to a half. And then looking at the second one, it said that the shaded part is 4/4. Now that's not right, because hopefully we knew that 4/4 is equivalent to 1 whole. And the actual shaded part is 4/16. And 4/16 is equivalent to 1/4. Now you've got 2 more to try here. Have a go at these, pause the video, and again, looking at the shape and the statement, is it correct or not, and can you explain how you know? Pause the video and have a go. Here are your answers. So first question says that the unshaded part is 1/4. Well, in actual fact, that was not correct. The unshaded part was 12/16, and which is equivalent to 3/4. And for the final one, it says the shaded part is 1/2, when in actual fact that's not true. The shaded part is 6/16, which is equivalent to 3/8. Well done if you had a go at those extra challenges. We're going to put some of those in for you to try each day now. So that's the end of our lesson. For those who want to carry on practicing their fraction work, they can go onto the MathsFrame website. You know the usernames and the passwords by now, and trying some of the different fraction games. But well done for today, and I'll speak to you tomorrow. Bye-bye.